let's see. So if I can, now strangely, okay. I'm not getting on the Zoom sharing. I'm not getting the choices that I hope to get. And so let's, I wonder. Okay, so let me find. So you should have found. Some so in the okay, so interestingly, it's not let's see, what is that share? Okay, no, that's useless. And so let's see if I can find my slides. And somehow it's not finding the or when I'm doing screen share, it's not letting me share the entire screen. So that's sort of annoying. And let's see if I do it. Okay, so now the PowerPoint is coming up. So let's try that one. Okay. So the I've got now I let you unmute yourself if you want, so you can ask questions. And the material is under flux because we're going to be doing lots of exciting and scary new things this time. The general idea of the option is whatever is current in places that might hire you. Okay, so like the whole point of BCIT is for you to get a job in the end. And you should have seen me before. So I'm still Bruce Link, and I'm still doing information systems. And the contact methods, the good luck with the office phone, good luck with seeing me in my office. And you know, so the email still works. And you know, I will eventually set up Zoom meetings for office hours and things like that, but I haven't found out my schedule yet. So that's waiting. There is a course outline, and you can find that. With the required texts, I'm leaving that to your discretion. So I did put up a text that covers part of the material, but people have tried to get by with only the slides with some success. So like there's, I will say leave that to your judgment. The same activities or the same marking things are there as before, but the plan is to do for the midterm and final, to do a practical midterm and final, which means that you're given something to code in a fixed time period, as opposed to a bunch of questions. Okay, that's not for a few weeks. And lectures and labs. Well, that's pretty typical, and I figured it's useful to say, what do I expect? And I expect you to develop into something exceptional, I guess, is the short version. Okay, so the expectation nowadays is that professional developers will learn over their lifetime lots of different languages and know the ones that they're using very well. And we can't cover all the languages. So the one that I'm emphasizing in this course is Java. In one of the fourth term courses, C# will also be emphasized. So those are probably the two main languages for the option. But when you're doing big projects, which we will do especially next term, then that's not enough. Okay, there's lots of other languages that can come in. Okay. Now, as well, I give you, like, you will be on various teams, so you learn by doing things and by contributing to the teams. And part of what you're learning is to work hard. Okay, at least that's the ideal, and that's partially why you're being hired. Is because employers believe that you will work hard, that you had to work hard to get through the program, and therefore you'll work hard when they're actually paying you. So the okay, so introduction. Well, I'm assuming, like, my typical assumption is that you've remembered everything that you ever learned. Okay, so that may be unreasonable, but it prevents me from having to reteach everything that I thought that you might have learned, and then we can never cover anything new. So here's some of the stuff that you've covered other places. So HTTP, JavaScript, CSS is covered in a couple of other courses. And that's all very useful. Java, many of you I recognize from being through 1510 in Burnaby. So I'm pretty sure you've been through at least one Java course. Databases, you had a database course, and so I can assume that you know enough to get going anyway on databases. And so we're going to be putting the pieces together in strange and new ways to build systems. Okay. Now the other way. Okay, so I went through and did a quick survey of technologies that are used in full stack development or web development. Full stack is sort of a buzzword, but it's a common one. And there's no end, basically. Okay, so this is just a few of the things that people use in what they call full stack development. And each of these boxes is a significant technology that takes a long time to be proficient in. Now, okay, I would say that some of these boxes you've heard of, but some of them you probably haven't even heard of. Okay, anybody want to claim that they've heard of all of these? Because some of them are quite new. On the other hand, I'm assuming that everybody has heard of HTML. And let's see, I don't think it looks like I didn't put raw JavaScript. That's because HTML5 includes JavaScript and CSS as part of the standard. Okay. Now, in many cases, some of these are choices. So on the upper left, I've got React, Angular, Vue, which are three quite popular JavaScript frameworks. And unfortunately, they all take a long time to learn, and they're mutually incompatible. And none of them has won. which means you can't just pick one, learn it, and you'll be okay. And probably nobody is confident in all of them. That's not that usual. So for a project, they pick one, they use it, and there are good reasons why you might pick one versus the other. I'm not going to go over that now, but in many cases, to survive, you have to get a meta understanding of what's the framework that these are all fitting together in. And if you can understand the basic architectures, then your life is simplified, and you can then mix and match the various pieces. So to get you up on the architecture, I have to pick a sample to actually cover. And that's what I'm doing in this course. But that doesn't mean that the others are bad. And it doesn't necessarily mean that what I'm doing is the best, because probably there is no best. But you got to start somewhere. Okay. Now, one of the things that I'm going to be doing to a greater extent than in the past is explicitly bring in cloud services. So it turns out that historically people had a server and they would install some sort of application server on a piece of hardware, and then they would install software on that, and they would run websites, that sort of stuff, have a database. And a lot of people still do that. That's probably the baseline. But over the last 5 years especially, people have been trying to offload from specific hardware devices sitting in their basement somewhere to using some sort of cloud services. And so it gets more and more important to know about that. So I introduced that to students last year, and last year students did in fact deploy their big projects on the cloud, on basically our cloud, i.e. information systems. And I'm pushing that forward to this term for this group of students. Okay, so that means that you have to know a bit more about what does that mean. And again, it's there's lots of concepts, and for this term, you don't need to go into it super deeply. We'll go into that a bit more deeply next term. Okay, so cloud turns out to be an overly used word, like many things in software. So a cloud in general could refer to automatically giving you a host with its operating system, or it could mean automatically giving you containers. It turns out that the containers are a much more efficient way of going, so that's sort of the way things have been leaning. So the cloud that we're going to be using here is called a platform as a service, or PaaS. And most of those run on Kubernetes. We're going to be using the OpenShift dialect of Kubernetes. So you have sort of an organization, which is a control plane that's making everything work, and then stuff actually runs on individual nodes. So a node is like a hardware box with an operating system. Okay, so what's on a hardware box? Well, it turns out that they're almost running, all running Linux as the underlying operating system. Now, most of you are probably not running Linux, although you might be. Most of you are probably running Windows or Macs. Okay, it's rare that I get somebody that's running Linux on their desktop or laptop, although it does happen occasionally. But it turns out that at first blush, it's not so critical what it's running. Okay, it's running Linux because that's the most efficient way to go. And on that is some things that keep things working. So like there's a kubelet that orchestrates everything that's running on, and the individual things are running in pods. So when you run a database or web server, you're running it inside of a pod. Okay? So there's a lot of jargon to get used to. So here's what runs on the control plane, basically to make everything work. Okay, so there's an API server that the world can talk to. There's some schedulers to allocate the hardware to the things that are running. Okay, and you get down to what concerns us, and the thing that you have to be most concerned with is our pods and containers. This is stuff that's actually running your applications. Okay, so I have a slide that gives you a little bit of overview on what's involved with that. Okay, and so pods contain containers. And what's a container? Okay, well, I'm not going to read all the words. You can read faster than I can talk. But basically, one of the things that you might have seen, and if not, it's good to expose yourself to it, are these container things. And Docker was the most popular. So I gave you some pointers to getting started with Docker. Okay? And in next week's lab, which isn't actually adjusted yet, we'll start off with that. Okay, so that's the what the stuff is running on. As well, the stuff can run on your laptop directly. So in other words, your laptop can be viewed as a host, or if you have a desktop, that as well. And on that, you can run a server, which will then run all these technologies. Okay. Now, my demos are going to be running off of the cloud, our cloud. Now, by the way, how do you get to the cloud? Okay, well, you'll need a login to get onto the cloud. And to log in, you first have to have an account. And the thing that I use for the account is our GitLab repository. Okay, so that's why I said one of the first things you need to do, which you should do this week, is create a GitLab account. And by the way, and as I mentioned to you in the handout, that's actually running in BCIT, even though the URL is infoteach.ca. So it doesn't sound like BCIT, but if you look at it, if you look at the IP, you learned about IPs in the Datacom course, then you'll find that that is indeed running at BCIT in Burnaby. I've never actually seen the hardware because it's in IT services somewhere in the back. I just have to trust that the hardware is there because it actually runs. Okay. So once you get over the basic infrastructure and you want to run something, then you're into individual technologies through the pieces. And in Java, it's acronym city. Okay. So the names are too long, so people will generally use the acronym. So here's a list. And these are things that we'll learn to some level of detail. We'll learn most of these this term, and some of them in more detail next term as well. Okay, so the net result of all this massive amount of scaffolding is that you're building something. And if you looked at the tools installation document that I emailed out, and there's a few changes, you can get it now from D2L, now that you're on D2L, there is a pile of software tools that I'm asking you to install, right? It's, when I look at the whole list, it's ridiculous. But there you go. That's what people use. And so you want to get the things I said you had to get this week, you should get by this week, and as much as you can of the rest of it. One of the things that you find when you're going through technologies is that very often you won't have the tools that they require. So you'll have to take a pause and then go out and find the tools, find tools that work on your operating system and get them installed or workarounds. So that's part of the learning exercise on your way to becoming professionals. And so I've tried to give you pointers to everything that I need, but there's then still the work of going through and doing it. Okay. So there are lots of other courses that you're taking, and they're presumably all useful, otherwise we wouldn't have them. The basic idea of building an application that is big is you break it into pieces, and then you go through and build the pieces, and then you put them together. And so you have to get a feeling for what pieces are going to work. And that takes experience. So that's part of what you're getting this term and next term is the experience of doing that. And historically, people broke things into pieces, they put the pieces together, and they wound up with one big massive thing, which was called a monolith. And they were still broken into components, but they were all run together. Now, recently, i.e., mostly the last 5 years, but more and more recently, thanks to initially Netflix was sort of the culprit of creating it. People decided to say, well, okay, we can decompose a big problem into small microservices that more or less independently can run. And then that gives us a whole lot of benefits. And so now you've got these two choices. What you'll see everybody saying is faddish is microservices, but in fact, most people are running monolithic. So the world is in transition, and we'll probably always have both of these. Because the microservices have a lot of good things about them, but they also are relatively inefficient in their use of resources. And they do that in order to give some of the benefits for massive architecture, such as Netflix. I mean, Netflix, I don't know if you have Netflix accounts, but they were sort of the first one. Now, Amazon, lots of people have something similar, a streaming service. They had to deal with, hundreds of millions of clients. That's a big system. And most people aren't doing things so big so that the monolithic actually works well too. So we're going to be talking about both of those. Either one has components which are implemented using technologies. So you have to know a bunch of technologies. And again, I'm picking some to get started. And those are the ones that I'm covering. Okay. So I'm assuming that you already know how to build some level of JavaScript interface, because that was covered in 1536, I believe it is. And so I'm covering an alternative in this course, which will weave in and out, which is Java server faces. So the idea with Java server faces is that on the server, you compose the user interface and then you deliver it to the browser. With a JavaScript user interface, you're basically downloading the interface from the server to the browser, but then it's running on the browser. They both will interact with the server typically, but the details are quite a bit different. So it's good to know both sorts of things. Okay, so that's and the chapters are referring to the required book, which you can buy it or not. I'm not requiring it as much as in previous years. Okay. All this has history. So people went through and with web frameworks dealt with the different pieces over the years. Okay. And one of the things about Java server faces is it's once you have the hang of it, it's quite rapid to use and easier to get going than a JavaScript client. It tends to be a bit less buggy as well, because the difficulty with JavaScript is it's very easy to have bugs that will take you down and flatten you. Okay. Now, of course, unfortunately, until you know how anything works, you can get flattened easily. Okay, and that's true with Java server faces as well as everything else. Okay, so there's a bunch of things that give you decent UIs with rapid development, and this is one of them. So that's sort of overview. So what does it give you? A bunch of standard sort of components. You can have them run with Ajax, which means that they give you a partial submission and react much faster than a full page display. They're event-driven. Okay, so what's event-driven? Well, just about any GUI reacts to the user. The user does something, the GUI reacts. And the way it reacts is that the user does something that generates an event, the system responds to the event. Okay, and you can do that in JSF as well. Lots of third-party tags that give you different looks and feels, and there's a lot of IDEs that support that. And by the way, the okay, oh, I didn't put it here. I don't really care what IDE you use. I'm demoing with Eclipse, but IntelliJ is popular. Visual Studio Code is more and more popular these days. And I almost switched to Visual Studio Code this year, but I'm not at the point where I like it as well, so I haven't switched yet. So again, you've got choices. And even though I might suggest something, that doesn't mean that you have to use that if you have another choice that you like better. If you want to ask me about it, you always can. Okay. Now, one of the things that you'll need running any sort of web things is a web server of some sort. And again, lots of choices. So for this course, I'm using a thing called Wildfly, which is pretty lightweight compared to most of the alternatives. And it's also free. And so the tool setup points to that. Okay. And so I'm not going to say much more about it at the moment. So for example, okay, so let's, okay, stop sharing that. And what have I got? Chrome, let's see if I can share. Okay, good. So here's a browser. And so if I click on the tab, so this is our cloud, and there's a GitLab login, which is how you will log in once you get a GitLab account. I've also got a login password, and so let me log in with that. Okay, and move that up so I can see it. So, okay, so this, I talked about pods. Well, we're running 253 pods at the moment. There's a lot of stuff going on. And if I go to the developer view, and let's see, so I want to go to the Comp 3910 project. And so I've got, I downloaded a couple of the examples here. And so here's one of the, so each of these is a different, you can think of, if you want to think of it as virtual machine, that's okay, but really they're pods which contain containers which are lightweight virtual machines. But if I want to click on the open URL, okay, so now it's running, and let's see, make it bigger. So here's basic login. So enter your name and password. and Fred and some password. Click on the login button. And it says, welcome to Java Server Faces, Fred. Okay, and I can go back. And I think there's also an Ajax one, which, if you look at the okay, so we'll do login Sam, a password, and then if I say login, then I stayed on the same screen and changed part of it. That's what Ajax does. So now I could equally well, as I'm typing the individual characters, display them at the bottom. That's like an echo Ajax, but this example was not until I click on the login. Okay, and then I go back. So that's basic example. And go back to my slides. So that has the URL. Now, if I'm running it from my laptop, then I would use a laptop relative URL. Okay, and you know, I can do that as well with a little bit of different sharing. We saw the result. These screen captures are from a laptop version. And we need to know, how does it work? Okay, so for that, I'm going to switch and see if I can get Eclipse running. Okay, so somewhere I have Eclipse. And so what have I got? Okay, so if I go into, so on the left-hand side here, I've got my chapter 1 login example. And I've gone through the installation instructions I gave you. So I have a server running, which is the moment it stopped, but down at the bottom, you can see Wildfly 20 in tiny letters. And I've got on the left Java resources, and I imported this. How did I import it? Okay, well, I went to Eclipse file, import, navigated to where I've got the code. Okay, and by the way, where is the code? The code is on GitLib. So by now you should know about Git, and you should be able to download the code, especially if I remind you where it is. And so we've also got web resources. And under web app, we have the actual code. So here's the code that was on the slide. Source. Trying to make that a little bit bigger. So what do we see here? Okay, so this might look a little bit foreign, but it shouldn't look totally foreign, because you should have seen HTML pages before. Okay, well, this is encoded as XML. And okay, so, but there is some stuff that's familiar. So if the first familiar thing should be this doc type. Anybody want to tell me what that means? You all unmute yourself. This you should have seen a long time ago. Anybody? Hello, hello. Okay. So that means that it's HTML5. And so we have an HTML tag, which you've seen before. And then there's some stuff that maybe we haven't seen, which is this XML namespace stuff. So that defines where the resources are. And again, this is the various tag libraries that we're using that creates the elements that are going to be displayed. So when we say XML and H, that defines a prefix, H, and it says, okay, well, that's corresponding to this string JSF/HTML. So that's a bunch of JSF tags. Okay, fair enough. And then we have, instead of a head tag, which you know from HTML, we have an H head tag. Okay, well, that's a JSF head tag. And among other things, that can have an output style sheet, which is a convenient way of getting a CSS file out there. Okay. And then in the body, I have a standard HTML tag, H2. And then I have a form tag, which in HTML has a whole bunch of other arguments. But in JSF, it's a lot simpler. I just have to say H form. And I also have a panel, which basically displayed a panel on the home page. And that takes me down to, that has a link, H-link, which generates a link, which when I click on it, sends me to another page, a login page. And if I look at the login page, that was the second page I went to when I clicked. Well, again, I've got an H head. Now I've got an H body as well, and a form, and then please enter your name and password. This is using a plain old HTML table to do the layout. But there's an input tag, and that has sort of some unusual syntax. And then there's a password tag, which is called an input secret tag tab, and or rather, box, and then that has some other syntax. And then I have a button, and I do that with a HCommand button tag. So that displays a button. Okay, so this is a mixture of stuff you've seen before and stuff that's totally new. Now, there is a subtle issue, which is that even though this is a totally trivial application, I managed to type something in on one page and get the data, the username, to display on a second page. So the question is, how do I get the data from the first page to the second page? If this was all in JavaScript and the same application is displaying both pages, then I can just have a JavaScript variable somewhere. So that's one way of solving it. But this is using a different solution. This is saying, okay, I want to store stuff on the server side for a variety of reasons. One thing, it's a lot more secure. And so my 2 pages are independent requests. So I need to somehow get the information in from the first page and then available for the second page. And to do that, then there's what's called expression language. That allows you to say, I want this to go into a Java object called user into the name field. In other words, whatever was in this input box stored in this backend Java object. And similarly with the user password, stored in the password property. Okay, well, where is user? Okay, so if I look at the user bean, then, okay, well, annotations. Okay, this is something that you saw a tiny amount previously, but we'll see a lot. In Java, annotations start with an @ sign. So this says, this bean, okay, well, what's a bean? It's basically a Java class with setters and getters. A few other things I'll talk about in more detail later. And I want to store it somewhere. That's one of the things that beans have is, and this says I want to store it in the session that's associated with this application. So that's what the next annotation does. And the rest of it is just a Java class. There's nothing special. So I've got, I guess, 2 fields, name and password. And they have getters and setters. Get name, get password, set password. Nothing new about those. And then there's also a method, a getter for a property called greeting. Okay, which doesn't correspond to a field. So a property, it turns out, you might have heard this before or not, in Java, a property is something that has getters and setters. So getters and setters define a property, which will often correspond to a Java field. In this case, I've got 3 properties, name, password, greeting. 2 of them have a field, name, password. The other one doesn't have a field because it's really a read-only property. It's got a getter, no setter. So in the login page, I type something. When I submit the page, this syntax says store it in the Java bean. And if the Java bean doesn't exist, create one and store it in the session scope. And then by the time I get to the second one, it will already have been created. So I just store it in the password property and then navigate to the next page, which is the welcome page. Okay, well, what is the welcome page? That's this welcome.html. So that one, similar to the other one, and I say welcome Java server faces, and now I read the name property from that bean. So that's how I get the information onto the second page. And then there's a button that goes back to the index. Okay, so any questions on that? That's sort of the overview. There's a lot of stuff going on there that I haven't explained in detail. Okay, but we saw it work. Okay, so the take a 10-minute break, and then we'll continue on. And people that are here, okay, so Heihan is now here, and good. Okay, so I will continue at 11:30 then. So, okay, and Sung is there. Okay, good. Okay, so Sung is there. And Choi. Yes, Suki was there before. Did I get anybody else? Okay, so almost everybody's here. I'm only lacking one person, it looks like. Okay, so let's see. So we got Travis and Eric. Okay, so we got Eric and Daniel Jin. And let's see, how many Daniels do I have? Do I have any Daniels? Okay, so I'm guessing that's Daniel Jin. And I think I saw Ethan. And Gilman. Okay, so I still don't see Gyeongmin / Tyler. Hey Han, I saw. Okay, so Hey Han wants to. You want to go by Alex? Is that right? I'm guessing. So Alex, are you there? He may be on his break. Okay, so I'm gonna and begin. Yeah, so Okay, welcome back again. And so any questions? Yeah, interesting. So I see two brave souls with faces with Abir and Daniel. Good to see you. So obviously you're going to rise up to be the leaders. By the way, do you guys have a set rep yet? Not yet. Yeah. Now, interestingly, okay. So the now there seems to be a preference for using chat as opposed to saying something. And just think about it the other way. Like if I'm going to use chat for my lectures, especially given that I can't type worth a darn, it would be even more of a disaster than typically. So you have the ability to unmute yourself. So if you have a question, you can stick something in chat, and if I see it, that's great. But if I'm sharing, I might not be able to see the chat at a particular time. So you can also just turn on your mic and say, ask your question. That's fine. And if I can see your faces, then I may again find out who you are, and it's less on my standpoint. Oh, good, Fahad. Thank you very much. And I'm not going to do, ooh, Ricky. Well, I'm not going to welcome everybody when you turn on your cameras, but like I don't think it hurts just to have your cameras turned on, unless it turns out that we don't have the bandwidth to do that. But we'll see. Okay, so no questions from before. Then let me, like I do need to sort out why it's not letting me share my entire desktop, but hopefully that will be fixed by next time. I'm going to go back to Eclipse and okay. So, okay, so we were going through the code, and when I ran it by opening up the cloud version, clicking on a little icon. But there's a ways of going before you get there. Okay, so for starters, there's an extra file that you may not have seen before, which is a pom.xml file. And the reason for that is because I'm using Maven, which is another thing that you probably haven't seen before. So that we're going to start with that in Lab 1 next week. But Maven is basically a build system, and it allows you to build things from the command line, which is great. But Eclipse can import Maven projects as well. So that's how I got this login into Eclipse in the first place. And if I right-click on the project and then go down to Run As, then now can you see the pop-up? Is that visible? Okay, so you should see. Okay, so thank you. So I've got some Maven things that I can do to it, but what I want to do now is run it on the server, because this is a server application. So if I click Run on Server, and it asks me which server. I've only got one of them that's in this version of Eclipse, because this is a brand new version of Eclipse. So I could say always use this, and then I wouldn't see this part. In any case, I can go Finish, and it will go through, and if the server was stopped, it will start the server, and I'm going to stop the server and go back to servers, and it shows me that it is stopped. I don't think it's that easy to make this bigger. Okay, so if there's a little arrow that I can use to start the server, I do that, click on that, and then it will go and I will see the startup text. And again, another wall of text. Info, there's one warn. I should perhaps look at the warnings. The info things I can ignore. And then it says that it started in 10 seconds. That's a little bit slow, but what the heck? So now the server is running. Okay, and if the server wasn't running when I said run as for the application, it will start the server automatically. It was running, so it started up and then it displayed the page. And this one, to make that bigger, I know. So unlike a browser, Eclipse isn't letting me make this one bigger. But if you notice at the top, I've got a URL. And if I take that same URL and copy it and open up a browser, then I will get the same display in the browser. Eclipse gives me a simulated browser, which is useful for development. And with the simulated browser, I can then click on that and I get to the next page. I can type in whatever I wanted and password, click on the login button, go to another page, and Eclipse will often give me a very good simulation of what it's going to look like in reality. So basically, I will use Eclipse or something else to debug my application. And then when I've got it debugged, I can run it on the cloud. Okay. Now, say I've got my application built, and then all of a sudden my laptop crashes, the hard drive is toast, and it's gone. Okay, well, potentially that's a disaster, except if you've learned about source code control and Git. Okay, so the thing is, it's in a repository somewhere. So when I'm making changes and I get the changes working, then I commit them and push them up to my repository. So where's that? Okay, so we need to go back to Chrome. Here's Chrome. And we saw this earlier, and one of my tabs is the GitLab repository. Okay, so I'm in root, so we'll sign out of that. And we'll sign in, see if it has the right password. Okay, so it does. So we're on chapter 1. So it turns out that there is a chapter 1 login in GitLab. And this is a public repository. So if you go to gitlab.infotech.ca/bdlink/ch1-login, then you can clone it yourself or download it and go from there. So if my laptop crashes, no problem. I just go back to the repository once I've built my laptop again, clone it down, and then I can work on it further. Okay. So the examples, most of the examples are up in the repository already, but some of them may change by the time I get there. And then to get them into, this is like a 30-second version, to get them into my project, well, first I need to create a project. Okay, so you will have permissions when you get accounts to create projects. And then I click on add, and I guess from the catalog, and down at the bottom, there is a Wildfly builder image. So this allows me to build a Wildfly pod on the server. or sorry, on the cloud. So I click on that and click on create application. And so it says, okay, I want Wildfly 20, so that's good. And then I put in the URL to the repository, okay, which was that. And let's see, GitLab. Yeah, that's okay. It will. It's GitLab to that, and I can change a variety of things. And then I say create, and it will create one, which I'm not going to do because I already got one. So it's relatively painless to push your application once it's in the repository to push it into the cloud. But this is sort of the substance for labs and not for what we're talking about right now. So basically, you can debug everything on Eclipse. And while you're doing that, you should have it in a repository. And I give you repositories in Canada. It will work with GitHub, but there you're storing it in the States. And I've set it up so that once you create a GitLab account, you have repositories that you can use, for pretty much wherever you want. Okay, don't abuse it. If we run out of space, then I'll have to go in and start dealing with it. And it will turn out to be relatively easy to deploy it to the cloud. But you probably want to do that once you've more or less got it working. Okay. So there's a lot of moving pieces. Okay, so let's go back to the slides. And PowerPoint. Okay. So we saw the index. We saw the welcome page. I went through the user bean. And then there's a little discussion of how did that all work? Okay, which most people find extremely mysterious, confusing, and too much at the beginning. It gets better. Okay, so I didn't show you, but there's a configuration file, web.xml, and that defines what the welcome page should be. So a welcome page is something that you go to if somebody doesn't give you a specific page, but just gives you the application. And then it's set up so that it recognizes that URL as a JSF page. So it takes the index.xhtml and processes it as a JSF page. And then that displays HTML, which your browser can understand, and sends it back to the browser. The browser then displays it. So then I get my initial page, which had a couple of links. I click on one of the links. I go to the login page, which goes through the same process, converts it from JSF to HTML, displays it, sends it back to the browser displays it. And because it has a name in the bean that's referenced, then I can use it in expression language. And there's a little bit of boilerplate to tell the server that the class really is a bean. More on that in a couple of weeks. And then it was a login page, stores the fields in the bean, navigates to the welcome page, which then displays the result. Okay, so there's a structure. So with any web application in Java, there's a standard structure that they will all use, which again takes a while to get the hang of, but not too long. And you can zip it up and display it and change the extension from zip to WAR. And then you get what's referred to as a WAR file, WAR standing for Web Archive. Okay, it is using zip format, so you can, if you change the extension back to zip, then you can unzip it with zip utilities, which are available on Mac and Windows in any case. And the examples in chapter 1, which basically is a simple example, but it has all of the main pieces that the more complicated examples will have. So it's important and useful to go through the example and try and understand all the bits and formulate questions if you don't understand any of the bits. Okay. Now, you don't need any IDEs. You can do everything with Notepad or Nano if you're on the Mac. It's just that the IDEs make it a bit easier. But the thing is that the IDEs, in the process of making things easier, also hide some of the details. And you need to know the details if you run. So that's why I say that the IDEs help you a lot once you know what you're doing. They make it faster. If you don't know what you're doing, you're okay as long as nothing breaks. But in software, that's not our standard situation, is things not breaking, right? Our standard situation is things break, things don't work, and we've got to figure out why. So at that point, then the IDE doesn't always help you out as much as it might. Okay, so basically, you will go through the process. You will break things. Things will be mysterious. You will fight with things for hours before you figure it out. Once you figure it out, it will turn out to be trivial. And hopefully, you won't suffer too much before you get to the fact where more and more things become convenient for you. Okay. Now, in general, it's good practice to, if you're in a team environment, to separate the bits into things that different people can do. And in a professional environment, you've also got people that are not developers that have other specialties. Okay, so like you've got graphic artists, you got people that can do music. Okay, and those people generally, they spent their life learning their trade, and it wasn't computing. So the ideal situation is where the different parts can be understood by the people that specialize in those areas. So layout people understand CSS these days. They understand sort of page logic. They don't understand programming. So you want to pull the programming away from the presentation layer. Now that's inherently probably impossible, or at least very difficult with JavaScript, because JavaScript is a programming language. But people have been trying to compensate with that and have more component-based technologies, and there is some progress there. But on the backend technologies, so PHP, Java, C#, they've been dealing with it longer, and they've got better architectures. And the general idea is that you have HTML-like stuff for the presentation layer, and any logic goes into a programming language, such as Java. Okay. So with the stuff that I showed you in the JSF page, it's actually an XML document, and I started out with an XML tag that says that's XML, and then it goes into HTML, but HTML written in XML format. So that means that I can have namespaces declared in the tags. Again, that's new. That's saying which tag libraries I want to use to do the display. Okay, so that's one of the first things that we'll be looking at in the weeks to come. So what we saw in passing is some core things, and most of them were rendering HTML, and they were prefixed with an H. Okay, so the H tags, H head, H body, HForm, those generated HTML markup in the end. So that's why the HTML in the name. And most of the tags that you use in HTML will have versions that are easier to use, but also give you fancier capabilities in JSF. And those will, if it's part of the standard, it'll be with an H in front of it. If it's a third-party library, then they may have their own prefixes, like some of them had a P prefix. Okay. Now, a common issue that goes across lots of technologies is, how do I get information between the components? Okay, so that turns out to be non-trivial. So here I'm trying to get some information from the client, which is running in a browser, back to the server. And so basically, there is a technology that does that. It's called CDI, context and dependency injection, which is a little bit of a mouthful. But that's what was happening with this pound sign syntax. Okay, so pound sign says this is expression language. And I can then use Java in the back end, and this will attach it to the Java. So when I have so the user is referencing some particular Java actual object, and then a dot, and then I have a property. So a property is something that has a getter and setter. Okay, so this is an input box, so I want to store the result. Well, sort of, actually. To display the box itself, I'm going to have to read what's there to put it in the display. That's only really clear if I have an error and go back to the same page, so I redisplay it. Okay. So this will need to both read and write, but the net result is at the end I want to write. So if the context is I'm writing, then we'll call the setter. If I'm reading, it'll call the getter. And it can construct the name of the setter and the name of the getter automatically from the name of the property, which is what you see here. Now, the thing is that somebody that's coding this page doesn't need to know all of that mechanics. They just need to know, how do I reference it? But for the programmers that are doing the back end, they need to know, this with getters and setters and so on. Okay, so this is syntax that we will see a lot. This is just the first version. Okay. As I said, the XML pages or the JSF pages are XML documents. And there's no need to learn tremendously about XML. You can just sort of pick up bits and snippets as you go through, but here's sort of an overview of some of the things that are different. Like HTML doesn't really care about upper lowercase. XML does. And HTML doesn't really care about open tags. It can figure it out, but XML does. Okay, so these are things that are good practices. And as I say, the thing about XML is it's more rigorous than HTML, and therefore editors can check it for you. And then you have less chance of having strange things given to the browser. So it's yet another technology. Now, if I have a multi-page application, which is, again, not universal, but common, then I need to know, how do I get from page to page? In other words, what page comes next? So that is an issue. And there's different ways of solving it. And the simplest way is I put the name of the page in the tag. And so that's what's going on here. So so I've got the name of the page. In this case, it's login. I'm not putting an extension, so that's inferred. And the system will then look for a login, and if it's a JSF page, login.xhtml file. And we'll see that, in fact, this generalizes so that you can have this just be a string and then put the string into navigation rules and figure out what page to go next based on logic, on backend logic. And so it is possible, again, this is just a literal string, so that's naming the page. That means that if I'm explicitly naming the page, it's easier for small applications, but it's not very maintainable when I have bigger applications. It's easy to break. If I want to move the pages around, I have to go back and find all the references. Otherwise, I will have a dangling link. Okay, so there's a fancier navigation scheme that we'll see later. But the terminology is setting you up for that. So this login is called the outcome. The outcome is indicating where I go next. And it is possible to have expression language there as well, in which case backend code will give you a string which tells you the outcome. I don't need that for this week's examples. Okay, but we'll see that there are then navigation rules in yet another file, and that's about all that I'm going to say this week on that. Okay, so I give you an example of what to look forward to, and as well, as things get more complicated, then we can configure the pieces, and so then there are other files that come into that. Okay, and this is just sort of a heads up that isn't having to be worried about yet. Okay, welcome file is good practice, and I think, let's see, did I give you? There is one in the web example, which if I have time I'll get back to, but we'll see. And by the way, when you first run your own that's not copying one that I've got, it's amazing the number of things that can go wrong. So you actually will learn more by having things go wrong than by listening to what I'm talking about, because there's just too much stuff, you'll never remember all of it. Okay, so don't worry about if you break things. Okay, so development environments. Okay, so here I mentioned code. Code is popular. IntelliJ, Eclipse, those are all popular. It's a wash. I mean, they all do very similar things, and you will find people that will argue that one is better than the other. Okay, probably doesn't matter. Pick one, get good at it, be happy. Okay. Now there's a lot of moving parts in any framework, and most of them these days have a pattern underneath them, which is the model view controller pattern, which you may have seen in some Term 2 course, or if not, you'll probably eventually see it. And if you haven't seen it at all, not that big a deal. Okay, but the basic idea is that you have some technology that's used to display things. You have some technology that's used to tell you where you're going to go next, or to handle events to figure out what to do next. And then you have something that holds any data that's involved. And the data is called the model. The part that's displayed is called the view. And the part that gets you places or does things is called the controller. And the JSF framework itself is managing the controller. And then it turns out, because the controller basically is integrating both the view and the model. So there's some sort of display technology, which actually turns out to be a thing called facelets, which I don't have to talk about for a long time and it still works. And the model is stored in Java objects. And there's a whole bunch of jargon around those as well. And there's different kinds of them. Okay. The other pieces of the framework gives you automatic data conversion, including to types that we haven't yet seen. There's automatic validation. Again, it's to do professional web application of any sort, you have to validate everything that the user types without fail. Because users, I guess you can categorize them as confused or malicious, or a small percentage that know exactly what they're doing. But the vast majority of them have some level of confusion. And then there may be a few malicious people, fortunately not that many as a percentage either, okay? But even if they're only confused, they can enter things that don't make sense. So you have to validate. And if you wind up with a user that's malicious and trying to take you down, then you have to validate as well. But you have to validate even more carefully. So one way or the other, we have to do validation. So a lot of frameworks will deal with that in a nice way, as this does. The other thing that is you might have noticed is not everybody in the world speaks English. Okay, so people speak a whole pile of different languages. And if you're doing a fancy application, it's useful if you talk to people in their own language. So that's called internationalization. And so framework should have some way of dealing with that nicely. And so JSF does, and we'll talk about that. And then you want to have nice, look and feel. So there should be some way of having, writing your own components, or having people write their own components, and you can just use them. So JSF has that. Ajax, that's extremely common. And so you have to support that. And it turns out that JSF, although I haven't seen it used very much, the most common rendering is in HTML. But if you want, you can render in PDF or in other things. And it's nice if there are tools that support it, just because it's too hard doing things with Notepad. Okay, so that's all that's there. So in the initial request, when you wind up going to whatever the page is, it will read the page, process it by a servlet, and then it actually builds a Java component in the back end. So for each of the JSF tags, there's a Java object that's created. So I had a HForm. So there's a UI form object that's created. And for the name field and the password field, those are both input boxes. So there's an input component that's created in the back end. And there was a command tag. So a command object gets created. So there's basically a Java version running on the server that models what your form looks like. And in particular, each JSF component has a corresponding Java object. And that Java object is responsible for holding the data that's associated with the component. And it's also responsible for generating the HTML that displays it. Okay, so a lot is going on. I browse to this URL. It's recognized as a JSF page. It gets processed. A tree of Java objects is created. And those objects are told, render yourself. And so the system navigates through the tree and then creates the HTML page that gets sent back to the browser. So as I say in the slide, rendering the HTML is called encoding. When the result comes back, then I have to decode the result and find the components again and store what was entered into the form. Okay. So in general, when you are running a GISF page with a form, the form is displayed, and then when you click on the submit button, the result goes back to the same page that created the form, and that restores the tree. And then you go through the results and visit each of the components, and they say, okay, do I have anything? Do I have anything? Do I have anything? And then they store the data. And then they go through a whole process to take the text that's coming in from the post that was a result of clicking on the button. And so they will store the results as strings, which is how they come in, and validate them and convert them into the internal types, and then store them in the model. And to do that, it goes through a whole life cycle. And once it's finished, it will then navigate to another page, which in this case was a welcome page. All right, so you need to know, how does the life cycle work? And again, this is one of these things that if you don't understand it, you can go certain ways, and as long as everything works, you're okay. But at the point something breaks, you then don't have a clue. Okay, so to help yourself before things break, then you need to know what the life cycle is that it's going through. So how many phases? Well, that's the easy part, 6. What do they do? Okay, well, that's a little bit more. So here I've listed the phases. So the first thing happens is you restore the model, which is called restoring the view. And then you take the request values that are coming in from the post, and you apply those to each of the components. Okay, by the way, this I all said on the previous slide. And then each of the components validates its values. And part of that, which I said verbally, which isn't the name of the life cycle phase, it does once, well, before you validate it, you have to convert them to the internal type. Okay, so process validation is both as a conversion and validation. Once they're all valid, you can then put them in the model in the Java bean. So that way, nothing goes into the model that's not valid. Once all of the inputs have managed to pass validation and get stored successfully in the model, then you can do whatever the page was supposed to do, and that's called invoking the application. And then once you've done all of that, then you go to the next page, which is rendering the response. Okay, so in the next 2 slides, I give you text behind all of those. Okay, so this is in more detail what I've talked about. And again, this is all good stuff. Okay, so you need to know it. Okay. And so this is the first 3, and I've said all of those. Any questions? Okay. And you again, you know, if you want to get a copy of the book, there's lots of text to read on this. I try to be as complete as possible, but just by reading the slides, you're going to have questions, most likely. Well, that's okay. That's what we're here for, is answering questions. Okay. This week is sort of kick-starting you. And a kick is not always pleasant to receive, right? So in the word kickstart, which is a common word, we don't often think about the meaning of it literally, but if we do, there might be some unpleasantness involved. Okay, and that's just life. Okay, so this is the first 3 phases, and then updating the model, invoking the application. Okay, we haven't actually seen any application things because the first example didn't really have that because it wasn't doing much interesting. And then rendering the response. So here's a nice, useful graphic on all of that. And so the little green boxes are the parts that we saw in the initial example. And along with a couple of things that I didn't highlight, but was mentioned in passing. So the very, very, very first time you visit a page, you don't have any form data yet because you're actually using a get to get the page. And so I restore the view, which will create it the first time if there's nothing to restore. And then because there's nothing to process, I go directly to render response, which generates the HTML, which goes back to the browser. So now the browser has got a form, and then they can enter in data, and then they click on something. Now they have a post, and that goes through the same process, but now it's not an initial request, and so it goes through the whole life cycle. Okay. Now, for now, you can ignore the blue boxes of processing events because I haven't talked about that yet. The green is enough. Okay, that's complicated enough. Okay, so this is a good thing to be able to draw and to hang your understanding on. It's a good framework. Okay, so I'll look at a few things, but this is it for the slides. So the stuff that I'm mentioning is to go through all of it is going to take us the whole year. Okay, so there's a lot of it. So don't panic. Don't get overwhelmed. It'll be bad enough, but we've got a lot of time to go through it. So what I want is that by the end of the year, you're in good shape to go out and get a job in basically any place that's doing things with backend services of some sort, cloud or otherwise. Okay. So in a way, there is a cloud option, which is mainly covering, it's sort of leaning on the administration side, whereas we're leaning on the development side. Okay, so there's a little bit of overlap, but my experience is mostly on the development side. I'm not a competent administrator. Again, because I'm one person, you can only have so many experiences, and my experiences have all been on the building side. And the reason my experiences are there is because that's what I want to do, and that's what I wanted to do. So that's where my interest lies. But to set up the cloud so that you can use it, of course, well, there's a certain amount of building involved, which was fun, and there's a certain amount of administration involved, which for me is not so much fun. But those are resources I figured that would be hopefully fun for you to play with. And we'll see where that goes. As I say, I did this last year. It worked better than I expected. The students managed to survive, all of them, without too much bleeding. And one of the new things is that I've been waiting for a whole year is a newer, nicer version of our technology, cloud technology. Okay, well, that came out in the summer, and so I spent most of my summer reconfiguring our server resources, getting everything up and running, and getting it so that it would be pretty nice to use. It's not perfect, but it's a lot nicer than what we had in years past. Okay, so one of the things I was noticing as I was going through, some videos, is what is it that in the trade that people are assuming to be able to understand a video, and there's actually a lot of stuff. Okay, like you go through a professional developer video from Red Hat or somebody, Red Hat, Nginx, VMware, IBM, videos all over the place, and there's a certain level of understanding that they expect, which you don't have at this point. So that's one of my goals, is get you through to the point of where you do have a good basis for those things. And it will take a while. And so that's part of why those of you that looked at the document that I sent out, you should get the later one from D2L. There's a whole truckload of tools. Okay, it's amazing. And again, I was trying to preload things with tools that will be all that we will need pretty much for the year, except for the MedHat will throw in some .NET stuff later on in term 4. Okay. So, and if the world had gone to microservices, I could just cover that. But it turns out that the old stuff is still the most common situation. So I can't just throw out the old stuff and add the new stuff, which means that I sort of have to blend it. Okay, so that's what I'm planning. So that's why I say standalone servers are still quite common. You do have cloud stuff. That's all that people will tell you about, but that's not all that's actually there. It's a trend. And you know, JSF is a good framework to start learning it in. Most of the Canadian banks converted to using JSF some years ago. And on the other hand, that's not the only view technology. So again, if you want to say, well, okay, this other technology is much better, yeah, sure, why not? If you want to believe that, doesn't hurt you. It's probably not such a black and white thing, but there are a lot of technologies. And what I'm more interested in is a framework of something that is has a good architecture, so that you can learn the architectures behind the frameworks, and then you'll survive when people swap the technologies on you, because that will happen. As I say, even on the JavaScript side, people have been fighting for the last 10 years and not come up with one dominant technology, even in JavaScript. So like there's a dozen frameworks, all mutually incompatible. And people will argue over the top 5. And I would say that there's probably a clear winner of 3, but one of them looks like it's slightly better for enterprise applications that have to work. Another one is better for fancy things that don't have to work perfectly. So it may be that there are multiple niches and they never coalesce into one. So the word is polyglot. In other words, multiple languages. That's sort of where we are in the industry. People like their favorite tools, but in fact, it's not so clear. Some of it is just choice. So I'm not super invested in any of them, but I got to pick something to teach so that you'll learn. And so I'm going with JSF and Java EE. Okay. Because those are both commonly used in the industry. And again, there are alternatives, some of which are quite nice. But if I try to teach all of them, we don't even have enough courses to teach all of them. And certainly in one option, I've got to make choices. Okay, so that's what I did. And okay, so we're just about out of time. And let me unshare this. So any questions? You shy, bashful people. So I've got 4 people that have their. How many do I have totally? Okay, so 25 people, and so let's see. Who didn't I see? Is Keegan here? Keegan. I don't see a Keegan. Okay. And so somebody said that. that Tyler is in client server, I believe. Okay, so I'll verify that. See, it would be on my current list. I've got 25 students. If we get into the lab in January, there are 24 seats physically. And that's actually true in the other sets as well. The set sizes are such that we do not have physical seats if we actually get back at BCIT. Because we are oversubscribed and fewer people went on co-op, it looks like. So of the first year students, there's a lot more of them that showed up. And the decision was, rather than turning people away, we would just accept people. And, I mean, for virtually, that's okay. I mean, the technology will support it. But I'm hoping that we actually get back into our building in January. And at that point, we'll have to deal with how many people we have and whether or not we have to wheel in extra chairs, or if I have to give up the instructor workstation, so that the student can sit down. Don't know yet. But if somebody went to client server, then actually we would be back to the number of people that we have seats for. So that's one problem avoided. Okay. So now last I looked, and you can't see it, but if I open up my browser that I can look at, on GitLab, I only had like 3 students. So by next Monday, sign up for a GitLab account. One more. And a couple 2 hours ago. Okay, so that's much better. So, and then in the with your GitLab account, and obviously you found out what the URL was for that, then you'll be able to log in onto the cloud, and Monday of next week, I will give you things that you can do there. If you wander in by yourself, there actually will be things that you can do. Try not to destroy it too much before Monday, and we'll see where we go from there. I think, like my sort of back of the envelope sizing, we should have plenty of resources for what we need. But I will only know for sure after we have 24, 25 students doing stuff. And that's where it gets exciting. So as I say, this is bleeding edge things. The technology that I'm using, which is OpenShift 4.5, the general release was in July. The underlying technology has been around for like a year and a half. Well, no, actually closer to a year. So it's pretty mature. But the released version, the open source release version that I'm using, is brand new. So it should be fun. So you are using the latest and greatest for better or worse. So that means that we can expect that there will be things that don't work absolutely perfectly. I'm on a couple of working groups to sort things out, just in case. Okay. So any other questions? I need to leave you to go on to your next thing. Okay. So how do you use GitLab? Well, okay. So with GitLab, so John asked a question in here. So the class is live. Both lectures and live are all live. Lectures and labs are all live. And a number of things behind that. So that's what I'm going for. We'll see how it works. So GitLab works about the same as GitHub. So Yogesh gave you a little document on that. Yeah, once you log in, you'll see that there's references on GitLab itself to piles of documentation. So you can create projects. If you wanted to play with it before getting into the lab next week, go for it. I've got it open up so actually anybody in the world can create accounts on it. And I just sort of watched to see if it's abused, which so far it hasn't been. So you can create accounts, or you can create a project. When you create the project, it tells you how do you attach it to a Git repository that you've got on your local machine. And if you just follow through, it all works. And you have covered Git in other classes, right? So at least the term 2 projects covered Git. And I gave you some resources and suggested that you read a little bit on Git. But I haven't looked at this particular link that Yogesh has put up. Go for it though. And any other questions? As I say, it's going to be, should be fun. And you did sign up for something that's not trivial. And most students find that they learn a lot. Again, the students that are keen and want to learn more than the students that are trying to get by. And I don't really, I can't tell you what you want out of it. That's for you to decide. You know, whatever you want, however much you work, you're going to get corresponding value out of it. Okay, so I don't know if you have a class right now, but I will try and finish promptly. And now I probably better sign off unless there's yet another question. So welcome. Thank you very much. I remember many of you from before, so good to see you again. And hopefully I will see more people on camera and I can renew my acquaintance with you. And by the way, it's hard to tell from that, but I haven't been able to get a haircut in God, heaven knows how many months. And I don't know when I'm going to be able to. So I've been cloistered thanks to this stupid COVID thing. So we'll see. It's exciting for everybody. Ciao then. Bye-bye.
Thanks, Bruce.
You're welcome.